Hello, chemistry students. So I made this video. I put it together just to go through a couple of examples to remind you of reading, right? Reading the periodic table and looking at those orbital diagrams, those boxes that we saw, kind of like that Hog-Hilton activity. So this is our basic periodic table. It's an excellent one, and there's just a couple of things we want to do to set ourselves up for success. One of them, we like to move helium. I like to put helium in group 2 because it has electrons in the s orbital. And groups 1 and 2, we are going to refer to as the s block of the periodic table. All right, groups 13 through 18 are the p block, and the transition metals groups 3 through 12 are the D block. And we're not worrying about this bottom section, although this bottom section would be the F block, right? And it's based on those 4 types of orbitals. S, P, D, and F are different types of orbitals where the electrons are going to exist, right? 90% of the time. And so the s orbital holds 2 electrons, and so the s block is 2 groups across, right? So everything ending in this first column ends in s1, everything in the second column ends in s2, right? We know that. And in the p section, it's 6 groups, so we got p1 through p6, and d is 10, right? And that's why the f section down here is also 14. And the second thing we want to do is we really want to highlight those energy levels, right? The rows on the periodic table are the energy levels, right? This is how the periodic table was set up. We have 7 of them, right? So we want to use a periodic table kind of like this to come up with an electron configuration. So let's say we wanted to do the electron configuration for strontium, Sr, right over here. All right, how would we go about coming up with that configuration? Now it has an atomic number of 38, so we can take the 38 electrons and we can use that diagonal rule. All right, and for some of you guys, you're really good at that. So if you feel more comfortable doing it that way, stick with doing it that way. But what I want to show you in this video is we can just read from left to right. So you want to just put the 2 pieces of information together, the energy level and the section of the periodic table you're in. So we're going to keep moving. We're going to scan from left to right until we reach SR. So we're going to start in the first energy level in the S block, and it's filled, so we're going to write 1s2. So we've now finished the entire first row of the periodic table. Now we're going to move across the second row. We fill up 2s2 and we fill up 2p6, right? It's filled up, it's done. We are not at strontium yet though. All right, now we're in the third row. We fill up 3s2, we fill up 3p6. All right, 3s2, 3p6. All right, now we fill up 4s2, and the trick with the D block, the D block is always 1 energy level less. As long as you have that piece of information, right, and you can apply that, you are good to go. So it's 4s2, then it's 3d10, because it's filled up, right? Because we are not at strontium yet. And then we're going to fill up, we're back to the 4th energy level, 4p6, right? Because we're in the p section of the periodic table, the p block. So now, getting to strontium, we're going to have to fill both of those orbitals. So it's going to end 5s2. All right, so this would be the electron configuration for strontium, and it's as if we read everything, right? Every row, every block filled up until we got to strontium. All right, so let's try a second example. Let's do cobalt. And this one's not marked up, but we know these sections now. So we're trying to get to cobalt. So we go from hydrogen to helium. That is first energy level, s orbital, and it's filled up, so it's 1s2. Then we move through lithium and beryllium. That is second energy level, 2s2. Boron through neon, right? We just keep moving across. We are scanning from left to right. We're on the second energy level. It's a p orbital, and it's filled up, so 2p6. All right, third energy level, 3s2. All right, we move on into the p block, so we get 3p6. All right, fourth energy level, we're still not at cobalt yet, so we finish the S section, 4s2. All right, now we're gonna get to cobalt. Let's think about how many elements until we reach cobalt. So 1, 2, 3, 4, 5, 6, 7. We want to include the cobalt. It took 7 spots to get there. So this is 3, because the D orbital is always 1 energy level less. 3d7. All right, that's how we come up with cobalt's electron configuration. That is reading the periodic table. Again, it's based on the groups. The groups represent, or excuse me, the periods represent the energy levels, right? And there are sections, S, P, and D. All right, and it's however many elements into that section. So now we also saw orbital notation. So let's see what would happen if we wanted to put cobalt's electron configuration into the orbital notation. All right, so I'm just rewriting cobalt. It's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. All right, we can draw in all those arrows, right? So we would want to be in this habit where anytime we go to the p orbitals, we want to kind of draw them all up first, right? And then double them up. We talked about that, seat taken, all that good stuff. All right, up, 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 down, down, down. All right, so 3p6 is filled up, 4s2 is filled up, and now I have 3d7. And there should actually be a 5th box here. Apologize. So 3d7, 1, 2, 3, 4, 5. 5 of them unpaired, then we start to double up. 6, 7. Right? So cobalt should have these 3 unpaired electrons. All right. But that's if you have the configuration, you just fill up those spots. All right. And then it's only the last one that you have to be a little more careful with to make sure you have the proper number of filled and unfilled. So let's just do one more. Let's do silicon. All right. I'm reading across. So I'm always starting in the same spot. So I'm starting 1s2. All right. I'm still not at silicon. So I'm now going to 2s2. Right, second energy level, s orbital, filled up. 2p6, second energy level, p orbital, all filled up, right, before we reach silicon. Third energy level, 3s2. Third energy level, p orbital, 3p2, because it only needs 2 elements to get to silicon, aluminum then silicon. 3p2. All right. So I'm going to rewrite that configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 3p2. Ooh, sorry. So I will always give you the boxes if I'm asking you to fill out an orbital notation. I will give that to you, right? You'll have them already set up. It's just a matter of you putting in the electrons. But what would you do if you didn't have the boxes? What if you had this configuration and you were asked to rewrite it in that box notation? All right, well, anytime it was an s orbital, you would draw a single box. So the 1s2, you would draw a box, 2 arrows. Then it's 2s2. You would draw another single box. All right, you would draw the boxes in order of the configuration. 2p6, now you want to draw a triple box and you want to fill it up. All right, now again, I would say draw them all up first, up, 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 down, down, down. Almost sounds like a song. 3s2, single box, up, down, and then you would end with 3p2, triple box. All right, you draw them together to kind of show that they're kind of like this whole set. And 3p2, you would only have to draw 2 electrons. You would always start on the left and the middle, and there it is. This would be the orbital diagram for silicon.